Our topic for today is history of electricity. For thousands of years, people all over the world have been fascinated by lightning. Some people must have wondered how to put that kind of power to practical use. Imagine a world without light. But it wasn't until the 18th century that the path of everyday use of electrical power began to take shape. Let's get started. Around 600 BC, Thales of Miletus discovered when he rubbed an amber to a cut-off fire, the feathers will attract. Thales had discovered the principle of static electricity. Because he lacked the tools, no one really followed up on Thales' idea until the late 17th to 18th centuries. In 18th century, Benjamin Franklin reintroduced electricity to the public with his famous kite experiment. He and his son flew a kite on the long cord when the sky was cloudy. An iron key was attached to the end of the cord. As storm clouds approaches, the metal rod draw electricity, which Franklin called electric fire. When the rain hit the kite and the cord was wet, that electricity was conducted from rod to the key. The next milestone of electricity were Nikola Tesla and Thomas Edison in 18th and 19th century. It was not until 18th and 19th century Thomas Edison and Nikola Tesla battled over which electricity system, direct current or alternating current, would become standard. During their disputes, named the War of the Currents, Edison mastered the direct current in which electrical current flows steadily in one direction, while Tesla for alternating currents with a stream of charges that reverses directions every 50 to 60 times per second. Thomas Edison developed a light bulb in 1870. He began building a power plant producing electricity to homes. He opened his first power plant in New York in 1882. 2 years later, Tesla, a young Serbian engineer, packed his gear and boarded the next boat for American dream with a few clothes, navels, and 4 cents in his pocket. And a few weeks later, he arrived to New York City to work for Edison. Tesla started working the very first day he arrived in New York City. And after that, he was soon assigned to work Henry Villard Ocean Liner, owned by Oregon Railway, the first boat to have electric lighting. The generator that driven to power the ship was in bad shape, and Edison was surprised that Tesla had repaired them. Tesla also reassembled and redesigned the DC generators and machines that Edison designed and became the standards for use. However, several months later, Tesla and Edison parted ways because of conflicting business and scientific relationship. In 1886, the first commercial alternating current power system in the United States was built. The inventions of AC induction motor by Nikola Tesla in 1888 and Tesla coil in 1891 allowed the long-distance transmission of electricity. Those inventions led to the constructions of Westinghouse Niagara Power Plant in 1896, the next milestone in the history of electricity. The power plant had 37 power output. Additionally, it has 25 miles transmission line at high voltage 11,000 volts to Buffalo City, New York, ending the era of direct current. Our topic for today is what is an electric motor? An electric motor is a machine that converts electrical energy into mechanical energy. Most electric motors operate through interaction between the motor's magnetic field and electric current in a wire winding to generate force in the form of torque applied on motor shafts. Here's how an electric motor works. Number 1. Electromagnetism. When an electric current passes through a wire loop in a magnetic field, the loop experiences a force on each side that causes it to rotate. Number 2, torque. The motor generates a force called torque that's applied to the motor shaft. And number 3, motion. The parts that spin continuously, providing power as needed. Electric motors can be powered by direct current or an alternating current. They can be used in many applications, including household appliances, power tools, vehicles, disk drives, industrial fans, blower, pumps, and machine tools. be discussing on how to disassemble and reassemble the motor so that we can check the bearing and replace it when needed. I have here an electric motor 9 leads out and sort of tools needed like bearing puller, hammer, screwdriver, prying tools, puncher, marker, socket wrench, impact driver, and a multimeter. Some motors don't have bearings on the nameplate, then you need to disassemble it to look the number on the bearing. First thing first, we make sure that the place is clean. We all have the tools and materials that needed for the job. Let's get started and help me out. First thing we're gonna do, we will make a marker on both ends of the motor. Double check. Next, we need to remove all these 4 bolts. We need to spray a little bit. So the other side has already been removed. I will use this one. We need to remove first the wire so that no one will hold the cover of the motor. Anyway, I already marked this one. When you are going to disassemble your motor, marks the terminal of the motor. We're going to tape the wires. Okay, it's already removed. Remove the rotor. And sit aside and check the winding. The winding is still okay. I'll just need to replace the bearing. The number of the bearing is 6203Z in SK. Then after that, we're going to use the puller. We already removed the bearing of the motor. Then we're going to replace it with new one. Then use the wood. Make sure that it is flush. It's not yet flush, we need a little bit more. Okay, now it's flush. Put back the stator and put the rotor in. So this is the good thing if we have marker. You see here the mark 1, 1. I put the other side 2 on the other side so that you will not get confused. Number 2, we need to put back the cable. After that, we need to whack a little bit. After we whack it, we do like this. Thank you for watching and see you on the next video. If you like this video, please like, share, and subscribe. Have a good one.